And so as soon as we end at 4:45 today, we're going to have to leave the room and clear it. And the cocktail hour for those that have gone to the banquet will start, I think it's at 6 o'clock. So every year what we try to do with the Wireless Technical Symposium is bring you the leading movers and shakers in the wireless industry that have unique technologies applicable to what we all do. And as part of our mission to educate our members, to keep them current, we have these presentations. We put them up on our website. If you go to our new website, we've got a brand new website. You will find technical presentations from past years, and that information will be available for several years at least. But this year, we're going to do something really, really different, really exciting. Thanks to Icom and Ray Novak up here in front. Ray, if you raise your hand. We are live streaming this conference to anybody that cares to watch. So there are a lot of RCA members who cannot travel to California. There are RCA members who are not well. And there are RCA members that just don't have the wherewithal to come to the different venues that we go to. About every other year we're in New York City because that's been our traditional home for 100 years. But we started a process about 6 years ago of alternating that with also going to other places. So we've been in Florida, we've been in Texas, and now we're here in California, which is wonderful. This is Silicon Valley. This is the heart of entrepreneurship and technology innovation. So those that cannot attend were able to, in fact, watch this presentation. So we have a number of very interesting presentations today. You know, when I start to get people to do speeches for us, necessarily wireless savvy. So wouldn't it be wonderful if somebody could sit somewhere in a NOC, Networks Operations Center, and be able to monitor the health of a tower and its antennas? So he's going to tell us about that. We're going to have a break at 9:45. At 10 o'clock, we're going to have the first panel, which will be New Trends in Wireless Test Equipment. I'll be moderating that. And we're going to talk about a lot of things in regard to wireless test equipment, what's new, what's changing. Then at 10:45, we're going to do Technology is Easier Than You Think. I'm sorry, I have all this written down and I didn't change the slide. There you go. At 10:45, we're going to do Technology is Easier Than You Think. And Galen, our student, presenter. As you probably know, every year we have a student that Carol Perry discovers at one of her various trips to amateur radio forums where youth are encouraged to learn about technology through amateur radio. So Galen Aspogue is going to talk about technology is easier than you think. Then we'll have a progress report from Carol at 11:30. Carol is going to review some of the stuff that she's been doing with the youth. You know, a lot of people think that the RCA is just a bunch of old fogies like me that sit around and have tube radios. Well, I do that. But the future of wireless is actually youth like Galen. And one of the problems that we have all noticed, it's been the subject of several fellows' respondents' speeches in the past, has been the inability for us to attract new talent into wireless, especially technical talent. There's a lot of people that want to go into the fluffy stuff of marketing and stuff like that, but hardcore engineers, software coders and what have you that understand RF and understand some of the ins and outs of RF architecture and systems architecture, they are getting harder and harder to find. And as my generation grays and retires, who is going to fix all this stuff? Who is going to optimize these systems? So we have a major initiative that Carol has been carrying on for at least 2 decades, I guess, of attracting youth into the excitement of radio through amateur radio. And she will tell you about where some of these youth ended up. It's pretty exciting stuff. Then we're going to go to lunch. Always an interesting proposition. Those of you that bought tickets, Dave Byram will collect them. Those of you that did not, there is a nice bar and restaurant right around the corner. I haven't had any time to look at that. And then at 1:15, we have something really, really unique. We always have a keynote speaker for the main event, the dinner in the evening. But this year, thanks to Chip Cohen, we have a speaker, a keynote speaker for this symposium. And that keynote speaker is Professor Frank Drake. And if you don't know who he is, all you have to do is Google his name. This man has essentially spent his entire life searching for extraterrestrial intelligence using radio astronomy. And he is a legend in his own time. He has an equation named for him. He is chairman emeritus of the SETI Institute, and he has agreed to come and visit with us at 1 o'clock, 1:15, and he is going to tell us about his latest initiative. He's been given an infusion of funding of $100 million to be spent over 10 years, and it's going to kickstart some extra energy into his long-term goal of trying to find life out there. Then at 2 o'clock, we're going to have another panel, which is going to be on LTEU versus Wi-Fi, the battle of 5 gigahertz. David Witkowski, who's with us today, is going to be the moderator for that panel. He's got a number of interesting people. And again, that's spectrum related. You know, who's going to win that battle? Who's going to get to use 5 gigahertz? And can the two technologies coexist? We'll take another break at 2:45. At 3 o'clock, we have a very interesting, very detailed technical presentation from Dean Lawrence Larson. He is the Dean of Engineering of Brown University, a very distinguished individual. Unfortunately, he cannot be here today. He had a family emergency. He is going to present his slides remotely. I'm going to be his click monkey, and he is going to come into us via telephone connection. The gist of what he's presenting is the fact that the lack of spectrum, empty spectrum, creates all kinds of challenges in using white space technology for the RF architectures that we create, and what do we need in terms of receivers and transmitters that allow us to take advantage of white space, that is to say, spectrum that's not being utilized at a specific point in time. What do we need to do to design such architectures? Then finally at 3:45, I'm hosting another panel which is on in-building wireless. For those of you that are close to the cellular industry or the public safety industry, you know that one of the hottest buttons right now is, in fact, in-building. All the big venues have been built out, the big sports stadiums and the big auditoriums have been built out. So now the battle is what we call the middle tier of buildings. Those are buildings for whom there is no obvious business model for who's going to put in this stuff. Is it the carriers? Is it a third party? Is it the vendors? Don't know. The panel will explore that with me, and then at 4:30 we're going to have a quick wrap-up. You will have a chance to ask questions of every panelist. I have assured every panelist and every speaker that they must reserve 10 minutes at the end for Q&A. But we're going to have to adhere to our timelines very strictly, because at 4:45 we got to get everybody out of here because of the main event that's going to be in this room. So with that, let me line up Clint Smith, and I want to welcome Clint Smith from Rivada Technologies.
First I'll say is wow. Okay. That was the theme of this, that's the theme for today. So, all right, my name's Clint Smith, and I'm the CTO for Rivada Networks. Effectively, can everybody hear me in the back? Just want to make sure. Okay, I see. Good. Never sure at times. What I'm going to present here is a, in short, is what I'd say is fairly unique. And, okay, all right. Specifically DSA, and I'll go through the slides, but I'm just going to cue this up just to help things, because I'm going to roll through a bunch of slides very quickly. And at the same time, I don't expect, there's a fair amount behind this, so I'm going to basically be doing a very quick drive-by on you, for this particular piece. When I'm done, as I go through it, you're going to have a series of questions. With the time frame, we may be able to get to them. If not, we can hit them offline or outside, at the end of this. Looking forward to an active debate on this. Now, specifically, some of this, for today, DSA is dynamic spectrum arbitrage. It really should be for capacity, but as you go through, you'll see what I mean by that. I'm going to describe what DSA is. I'm going to go through the different components that are involved with DSA, and it's very unique on that. I'm going to go over a concept called DSA Flex, which has got 3 different variations to it, and I'll show you the differences, and there's some commercial reasons behind each. I'll go over an item called a lease, basically a capacity lease, which is rather unique, because that's currently not what's being done right now, and I expect this is going to lead to a fair amount of queries, and it'll be a very fun debate. Then I'll just mention, just go over some of the IPR associated with Rivada, just as a curiosity point from an engineering aspect to show not so much that we have the IPR, or I've got all the IPR I filed for, and because it's just some of it, but it's to show you how we've approached this from an entire ecosystem point of view, and that's really why I've got that in there. All right. So, and we'll see if I can work the slide, the clicker correctly here, which is nice. Okay, effectively, DSA, we call it dynamic spectrum arbitrage. You can think it, at the end of the day, what we are moving for is to commoditize wireless bandwidth. Now, that's a very unique concept, because right now, wireless is not commoditized. And this is a unique, right now, when you look at it, we are going on the approach to treat it like you've got a barrel of oil, and in that direction, so that you can actually trade it on a commodity exchange. This is a very unique approach, at least I believe it is. And so when we mention capacity, we are trading capacity from one network to the next. Now with this, DSA effectively decouples spectrum ownership and wireless service. So at the end of the day, right now, you're associating wireless service with a particular wireless company. They're directly coupled with their license. What we're doing with DSA is we're decoupling that particular aspect. And I'll cover a few of those things with that. So basically, DSA allows an operator, as I'm just reading through this, to lease excess capacity from one wireless system to the next. It's going to allow MVNOs and everything else to actually come into play. And what we're doing is we are basically commoditizing underutilized capacity in a wireless network. Because in every spot in a wireless company it's like, I'm going to just pick on Verizon and Sprint and T-Mobile and AT&T, capacity is not uniformly distributed throughout their entire system. And this allows somebody to sit down there and say, like, lease, in the future, not right now, but in the future, AT&T could lease some of its excess capacity to Verizon, and Verizon can lease it over to T-Mobile, and over specific geographic locations and specific times. Now, DSA is going, from our view, is going to foster new competitors, and it's going to basically approach on a non-traditional approach, and it deals with a lot of roaming. There's some very interesting roaming partners that come up on this. Now, effectively, it's an open access marketplace. That's what DSA is allowing us to get to. It's looking at an open access marketplace. And as I kind of mentioned, it's going to lead to the commoditization of spectrum, and it's really capacity. Now, it's not, as we go through it, it's not for, let's just say, just as a concept, the capacity could be, when we're envisioning it, we're going to get it down to this room in terms of size for actually leasing. It's not, right now, currently, if you do a typical roaming process, you would have for the entire MSA that somebody would have for a wireless carrier. What we're doing is we're saying we can get it down to a specific geographic location, and our objective is to get it down to well within, say, like we can parse it out by a room. And that's a bold statement. That's pretty wild when you hear it on the first time. And we'll start going through how we're actually we're able to do some of this today. All right, let's see if I can get the next slide. Now, one of the things that we did when we put this together, and I'm paying attention to my time, John, so on DSA is that I didn't want to introduce changes to the wireless companies, for your fundamental infrastructure. And that's a little bold statement in terms of how to look at it. But effectively, DSA does not require provisioning of the USIM on a handset. There's some new stuff that's coming out, like files and a few unique services that are coming out that you have to actually provision your USIM. That's the your SIM card that's on your device. We don't need to do that. And that's one of the first bold things we do, because to be effective, I want to make this transparent to the end user. I don't want the end user, which is the end customer, to know that we've done anything. This experience should be transparent to them. Now, it doesn't require any modifications to the OS on the handset. As I kind of mentioned, that's one of the directions of a couple of the major players are going on. And frankly, I don't think that's really necessary. We're able to do it from the network aspect. And basically, DSA enables dynamic usage consumption and tracking in geographic defined areas. As I was mentioning, we can do this room as we're going forward. Now, DSA fosters where we see this happening, is DSA is going to enable a lot of small entrepreneurial companies to emerge, because we're breaking down the barrier for gaining access to wireless bandwidth. And that's a very important thing in terms of how we're going on this. Now, one of the things that's interesting is that when we began this process, and it's been an interesting road, but when we began this, the first lines we got is impossible, can't be done, you guys, no way, And the list of why you can't do it was far easier to see than the small list of, yes, I can do this. So we held ground. And lo and behold, what we're finding is on release 11 for LTE, release 12, release 13, they've integrated a lot of our concepts to make this happen. The industry is moving, and basically lining up with what we were proposing. In fact, Etsy went out and actually came up with a spec that actually is DSA. It's a very interesting thing that's happened. And what they call it, licensed shared access. DSA, they change a few little letters. That's okay with me. But as I say on this little slide, flattery is basically imitation is the best form of flattery. I'm very happy with that. And what this is really indicating is, if you look at Qualcomm, Nokia, regardless of what's being said when you say you can't do it, they're lining up with this. So everybody's smelling something on this, which is very interesting, especially with the 3GPP specs coming out and what's happening. People are paying attention to this, including, as a side note, you've got this country of Mexico, which is issuing an RFP that is going to allow 90 megahertz of LTE spectrum that's going to be leased on, that they want to have purely for a wholesale basis for MVNOs. And that's a really bold thing. Mexico is moving on this right now. All right. Well, what comprises DSA? Well, to make this happen, I've got an item called a DPC, and I'm just going to go through a list of a couple little components, and I've got a next slide that's going to go through some particulars of what the actual components are. But at the heart of this, it's a server. That's really what DSA is. It's a server. And we're using an Atka chassis right now, but it could be run on a Dell server. It could be run on basically a series of blades because it's a transaction-based process. At the heart of it, we have an item called a DPC, which is a Dynamic Policy Controller. And it communicates, the heart of this is we have a dynamic spectrum controller which interfaces to the wireless carrier. And we're doing this through the network management system, which is really bold. Why did I do that? Well, the reason why we did it is so I don't have to muck with the interior, I can handle it at the NMS for a wireless carrier. It's very bold. And also, on that. So for this to happen, I have to have a DSC. In this case, I've got two wireless carriers, which is what we've actually demoed many times. We've got two wireless carriers here and here, and we're using a dynamic policy controller to share lease information between each other. What we made a point to do is when we set this up, and I'll go on to the next slide, is that we're not sharing tactical or performance criteria or metrics between wireless companies. We made it a point not to do that, so they're isolated. I came from a wireless background, specifically from 9X and also Singular. I am a little sensitive to this particular end of the world. So from the initial onset, we set it up so that they don't communicate with each other. And that's why I have this item called a dynamic policy controller. But going on that, I'll go through a few terms here. The dynamic policy controller coordinates resources between two networks. So if you look at this guy coordinates this resource and this one. This could be the lessor, and this could be the lessee. When the lease begins, this is told to begin the lease. He contacts the lessor and says, set up your resources. And he also contacts the lessee and says, you now have resources available on this particular network. All right. Dynamic spectrum controller. Now, mind you, I came up with all these acronyms. Why? Well, I had 3 letters, and then I just had to name them. So, sometimes they're not best named, but that's what we're living with for the moment. So like I said, lease spectrum access, DSA. Yeah, to me, it's as long as you get the concept and what you're trying to do, that's really what I'm after. Dynamic spectrum controllers, it manages the lease at either the lessee or the lessor as part of the network. So the lessee could be, like T-Mobile, and the lessor could be Verizon. Or in the other aspect, the lessee could be a new MVNO that's put in place. We have an item called a bid manager, which is a GAA, and it basically, in the midst of this, you have to create a lease. How do you do it? Well, the GAA actually does that, and it's basically gives either the lessor the ability to actually post or publish the lease parameters, and it also gives the lessee a chance, or potential lessees, to evaluate whether that lease makes any sense for them to utilize. And of course, with everything, I had to come up with an element manager, an EMS, because that's required because you need resiliency on that, and there's a fair amount behind that. And the northbound interface is called an arbitrage entity. That interfaces to the commodity exchanges. And that's where we actually publish the lease to. So, so as an example, yeah, we could be tying into the stock exchange, or we could be tying into the Chicago Mercantile Exchange, or our own over-the-counter trading platform. And the AE basically publishes the lease, and then when the lease, during the time, all trading's going on for this lease, the DSC, the DPC doesn't really care. It's already gone. It's published. It doesn't really matter. It's only when the lease has to be executed, and that's a big thing that's happened with this, and I missed that point to bring that up from the beginning. The big difference that's happened with DSA and why wireless has not been able to be commoditized to date is you had no way of actually delivering the contract. You couldn't deliver the contract. So if we bid everything, yeah, we've been able to bid it, but what do you do with it? At this point with DSA, we have the ability to actually deliver the contract, which is extremely different. This is the key element that happened with this. We can deliver the contract. All right. Now in this, you would expect that we've got a few different variations. If you've got an MVNO, or if the situation is you've got two wireless carriers, the configuration is a little different. It's not the same. As as all of us in wireless kind of know, the devil's in the details. It always is. So I came up with a concept called DSA Flex because I wanted to have the thing somewhat flexible in terms of how to approach everything. And we've got three pieces on it. DSA X, which starts off, I'll hit that in a bit, but the two main ones that I really want to go through is DSA 9. That uses a MOCN approach. It's a multiple operator core network. And that's basically RAN sharing. Now you may say, hold it, we've got RAN sharing, we can do this. Oh, that's why I'm 100% 3GPP compliant, because I'm going through the NMS. DSA Lite, well, think about an MVNO. That's a pure roaming process, and that's basically using a gateway core network function. And that's following 3GPP's configuration for roaming. Once again, 3GPP compliant. But the key thing is you say, well, what's so unique? Well, we have the way of actually delivering the contract. Up until now, nobody's been able to do that. We have a contract delivery method. Ultimately, frankly, we see the world going toward a DSAX environment. And the reason why is we can get leases down to, if you want to get them to move to say like down to the minute or second level for how long the lease is going to be in place, or to shut down a lease within a minute or a second, we need the X interfaces, and I'll hit that in a second. So effectively, what I'm getting at is and I'll just briefly blow through the DSAX environment, but with all those terms I used in the past, this would be a typical, this is a lessee LTE network, and this is a lessor LTE network. The lessor, in typical lease terms, is a guy who's offering the capacity. The lessee is the guy that is wanting to purchase the capacity. And that's basically the two gists of it. There's a DSC that's here in both parts of the system, and they have communication, in this case, right directly inside the network. We have a GAA for actually creating the lease or reviewing what the leases are. A lessor, as an example, could also be a lessee. There's no restriction on that. We could be a lessor and a lessee depending on what the requirements are. It's back and forth. It's pretty cool that way. The DSCs are set up so that they can actually basically handle both cases and simultaneously, not just one or the other. You just don't do a single static configuration. At the heart of this, we have a DPC which communicates to all these platforms back here to each individual operator. As part of it, we have a security gateway that we set up, and we actually put in, we're in FIPS 140.2 compliance from the beginning, which is really bold because nobody asked for it. What we did, just to give you an idea for DSA, when we began to design, I went from where we wanted to be, and then we came back and said, okay, what can we do today? So we stripped down a few things. But specifically, DSA is a software-oriented architecture. Everybody talks about it. I did it. That's how I approached it from the beginning. That's why when I look at this, I can actually, because we looked at what the design requirements were, and we did it based on what services we wanted to deliver, not from a network aspect and having a network built and saying, okay, what services now can I offer with this network? we did it the other way around. We did it, I teach this in grad school, and it would be hard for me not to do this if I didn't actually go through and actually do it myself. It's kind of have to. Oops, one other thing back here. On the DPC context, the AE here, and that could either be commodity exchange, different commodity exchanges, and that could be, there's a variety of them. So I'm using the AE basically as a choke point to sit down there and deliver wherever the lease has to go. All right. Now the fun part is where we expect is DSA 9 and DSA Lite are the two configurations that everything's starting with, and that's where everything's happening. DSA 9 uses a MOCN approach, and the objective is I want to be able to move active subscribers from, in this case, from the lessee network to the lessor network when they're active. Not passive, active. That means a call's in session. We've got a data session happening. How are you going to do that? Well, we're using MOCN to make this happen. Now there's a lot more behind. This diagram is, I would say, it's missing. There's a lot of little connections that are missing here, but it's standard for MOCN. Now, we're using the NMS as our basically process. It's called the O&M here, but it's really the NMS or OSS, depending on what network operator you're talking about. And what the fun part is, when we transfer over from one network to the next, it's transparent to the subscriber. Now, we're using, and one of the key things that we're doing is we're transmitting the PLMN of the lessee on the lessor network. So just as a brief example, if you're Verizon and you want to lease some, or you're T-Mobile and you want to lease some capacity from Verizon, what Verizon's going to do is they're going to transmit the T-Mobile PLMN on the broadcast channel. It's called a secondary broadcast channel. And that's standard within 3GPP. So your roam light doesn't come on. The subscriber thinks he's on his home network. So therefore, instead of us having to flash out like you might, everybody knows, like the old PRL lists or everything else where we had to update it, I don't have to do this. It's there. It's treated like it's his home network right from the beginning. And we have that dance. And that's a standard function that goes on. Standard features, we just put that in. And as I kind of indicate here, it's using existing OEM features, original equipment manufacturer. It's basically like Lucent, Alcatel. They're the same now. That's right. Soon, no longer to be. Now they're going to be. I hope they don't call themselves Nokia, Alcatel for NA. Let's hope they don't go down that path. But you've got, with Ericsson, Alcatel, Samsung, we're going down that path using standard features and functions that they already have. Now each vendor's got their own little twist on things, so they're not, how they actually implement it's just a little bit different, but they're all very similar. And the quest is, once the lease begins, I want to start moving specific subscribers over. I don't want to move everybody over. I can pick, so like 5 people from that side of the room and 1 person from this side of the room to take advantage of that lease. I don't have to have everybody. I can pick and choose because I have something called the HSS, the home subscriber server. I actually read that, and I can actually steer who I want to send over. All right. DSA Lite, similar process, except the difference is I'm not sharing a RAN. I'm not sharing the same cell site, but I am transmitting the PLMN of the lessee on the lessor network. I am doing that right now. And that's really the biggest difference. I'm not doing network sharing. If you look back to this config, I've got a fair amount of activity going on between this RAN and this interior for the lessee system. There's a fair amount of activity, but it's all standard 3GPP. And I'm sure I'm going to get quizzed on a few things on that, and I look forward to it. For DSA Lite, it's a standard roaming function, where what we're doing is when you roam on the lessor network, the service gateway points to the packet gateway of the lessee system, and that's how it's done right now today. If you roam, that's typically how it's done. It's nothing standard, nothing unique. And that's a key point between how we've done with DSA. I've actually looked at how the systems are configured, and we didn't want to sit down there and start doing something very unique. because it's a hard enough sell to get it in this door without having to say, well, now that you believe this and to do this, now you have to change your entire network configuration. Now, I'll go right into the buzzsaw for the wireless operators, and I will not survive that run. So I'm not even going to try. I made it a point I wasn't even going to try to go there. All right. Now this is a very, very interesting chart here from my aspect, because if you say, okay, what do you mean by a lease? And I'm going to be very quick on this. If you imagine right now that this lease area that I've got drawn here covers the entire wireless license area, and as we know, BTAs, MTAs, MSAs, RSAs, they're all, shouldn't say, they all have an EAs and partial EAs. They all have different geographic boundaries. They're not the same. So when I say a license area, one wireless carrier, nothing is exactly the same. But at this point, I'm going to say, okay, this happens to be a partial economic area because that's the way we think it's going to happen. We're going to do partial economic areas. Now, for the lease, I'm going to say, all right, I could have one lease where I've got these 4 cell sites, or it could be 50 cell sites. That's going to be the actual lease area. Because we're able to do it through the network operating system, I can actually have these particular eNode Bs transmit the proper PLMN. And that's how they know where they can actually use that network. And we can redirect the mobiles to actually use those particular cell sites. And at this point, the initial start with DSA, it's going to be 2-dimensional, flat. It's just 2-dimensional. There's no Z coordinate in this. And okay, so it looks like this. Where we're viewing this is going is we call it the bandwidth orthogonal resource grouping, called the Borg. It's basically, and you may think that's funny, but that's actually the patent filing. I'm big with the names. So what we did here was, this is a cube. And we've got another piece of technology called LVS, enhanced location-based, but that's not the purpose for today. But we've defined this as a cube because for a commodity exchange, you have to define what the unit you're selling. You just can't say, I'm going to have a lease. You got to have some commonality. So what we did was we came up with a thing called a bandwidth unit. It's a geographic cube. Somebody can trade it. We approach it like a barrel of oil. What are we doing? It's enough. And so what we're doing is, on this thing, you could see that they could be all grouped together like this for some Z coordinate, or you can actually start parsing it out. The quest is we could actually start breaking it out to different parts of buildings. You could do air corridors. You could do a variety of things with this. It's just, the imagination is where this is going to go, and how the market's going to take off on this. We just don't truly know at this point. I could speculate a bunch of things, but we're starting off with a 2-dimensional plane, and the system is designed to go to a 3-dimensional right off from the beginning. All right. Now, as part of this question something I brought up before is called a GAA, and that's where you either post or publish the lease, put all the parameters in, or you review it. And in this case, what we have here is just a simple GAA where we have a list of cell sites. This little grid that's right here, it's a polygon as we call it. You can either follow a partial economic area or you can craft your own lease area. We could push the lease. As an example, Verizon could be saying, or T-Mobile, and I'm going to use these two, and it doesn't have to be. If T-Mobile needs capacity for its geographic area because they're experiencing a lot of congestion at a particular time, they could put a request out and find out who's got, through the DPC, who's got additional capacity in that geographic area for that spectrum for that given time. It's very possible to do it that way, and we've got the system designed to support that. Our initial piece is initially that we're expecting that it's going to be a push piece, or rather, leases are going to be published, it's going to be a little more static, and then we're going to get into more dynamicness as this goes along. On this particular piece, what we have is it's when the lease begins, or rather the bidding process, and when the bidding process ends, when the lease is supposed to begin and over, how much bandwidth we're going to offer, and the type. Is it based on how many terabytes we're going to offer? Is there a terabyte and time component with it? There's a few little variants, but effectively you're buying terabytes is really what you're doing for data in a geographic area. And if you're the lessee, what you do is you pull up your own system information on the GAA, you have your own system configuration. You can pull in your own traffic data, your own coverage information, and you just look at this particular grid and you see, does it match what I need? We're not sending from the lessor, the person who publishes the lease. He's just sending his geographic coordinates of the particular lease parameters, the polygon. He is not sending what cell sites are in there. All right. And just for fun, what I have here is I'm doing this quick little drive-by. This is just a high level of the IPR game that we're doing. And in order for us to try to approach this, a lot of times when you've got a vendor or somebody looking at a new piece of technology, they tend to focus on one particular platform, one particular area. In order for this to happen, we had to design the entire ecosystem, which is a very bold thing because it wasn't done. So in order to do this, I was stuck with the fact that I had to design the ecosystem, which included handsets to begin this. We started off with band 14, and for all of us that are in public safety, we kind of know why. And for a few of you, you may have seen when I actually had band 14 handsets actually working a couple years ago, where we were doing handoffs between two different networks with live video feeds. It wasn't cached, it was live video feeds. Because I wanted to show, because the best thing to do is show a live video feed with your face on it in the room to actually show it so you know that we weren't making a story up. Because a lot of times people tend to over-exaggerate things, and you still have that anyway, no matter what you do. But this basically goes over, I looked at DSA as 4 domains. You've got a financial domain, which goes into the bidding process for making the commoditizing and where we think everything's going. A policy domain, a network domain, and also a subscriber domain, which we've been pretty heavy on recently. And so that's basically where we're going on this thing. And I just want to point out that as part of this, on the overall DSA approach, when I went after this, I wasn't after a section. I was after taking the entire ecosystem right from the beginning. All right, the usual statement I got to do. All right, questions? All right, Harlan.
So this is very good. It's a good proposal, particularly from a customer's perspective. It's great. I mean, if I'm a customer of Verizon or AT&T or T-Mobile or whatever, I can get much more reliable service where they don't have coverage or have limited capacity or whatever. That's great for a customer. What I don't understand is if company A has a pretty good amount of spectrum, company B is somewhat deficient. I can see why company B would want to do something like this. It seems like company A, who has pretty good resources, would be giving better service to their competitors.
Mm-hmm.
So the question is, what is the advantage to the carriers who have lesser spectrum or to the ones that have more spectrum to entering into such an agreement?
Oh, spot on. The advantage, the resistance right now for an existing operator to assist one of their competitors, there is no advantage for them to do it at all. Right now, today, there is zero advantage. In fact, they'd have more reason to tell you why not to do it. And that's been part of our resistance we have, starting right out of the box. We envision that where this is going is the DSA Lite version to start with, not DSA 9, where we're sharing networks, RAN sharing back and forth. We're seeing this as really starting off as an MVNO process where we have new entrants coming in. That's how we envision this really to start off with. But the point is coming back to why would the big players want to play in this game? The answer is they have every reason why not to, because this is so disruptive. This is going to change how they do the licensing process. When I had to sit down with the FCC, they were, it was almost a year ago, they were looking at this and saying that we can now start changing how we offer auctions because the leases don't have to be, the licenses don't have to be for 10 years. This could be for a shorter period of time, and it could be more of a revenue generation piece from the government's aspect, and they don't have to surrender it. And we've looked at this for the military too, because it actually proposed for DSA for band 42 that they could actually use this DSA so they didn't have to surrender their bandwidth in the future. Now, whether you can change that machine, that particular ship in midstream, I just don't know. Okay, go ahead.
Yeah, would this be more applicable to allowing public safety broadband system, use commercial, spectrum and still keep, still have a way to keep their own whatever broadband system they wind up with separate, but still allow them to use the commercial capacity when it's available?
And the simple answer is yes. On this, there's a couple things that you kind of alluded to on this, which is very good. A lot of the the DSA process was a fair amount of this was pushed forward from the aspect for public safety. For FirstNet, and that's where it was before even FirstNet was envisioned. It was back in the days when Harlan was running the game overall, which dates a few of us, but I've got a whole room of people we can do that with. Okay, but the answer, directly answering the question, this would allow, because the DSC can both be a lessee and a lessor, this would allow us to basically get additional capacity from commercial carriers. If was needed, and you could prioritize what group you wanted to send over to, not because there's different groups, different like DPW, we may want to use send it over to the commercial guys, but then again, DPW at the time of the incident may be the highest priority because we need them to clear something. So and you can do it on a dynamic basis, which is a great thing called the HSS. We can move them back and forth. Now, as it starts with, like I said, for DSA Lite, it's standard roaming agreements, except the difference is that we've made it for a geographic area for a specific time. So we've put a time and location aspect with it. Now with that, and we've got the delivery method, because we can actually reach into the NMS and actually make the changes there. But coming back to your point, yes, we can definitely. There is no reason why public safety couldn't leverage the commercial capacity for the geographic area. With that said, there's a lot of details that have to be worked out. But technically, and to me, the details are more business oriented and not a technical aspect. Technically, there's no reason why we couldn't do it. Go ahead. Just.
Comment on that too. So the concept is really good for public, it could be really good for public safety. The part that doesn't work, and Clint knows this, so I'm not disclosing anything, but if FirstNet were to embrace this kind of technology, this way to do business, it would give public safety the best of all worlds. It would have access to its own spectrum and to commercial spectrum, and it could be arrangements. What can happen is that it cannot result in any financial gain to Rivada. The way the law reads is that any profits or any money that's realized has to go back to FirstNet. So there would be a different business model, but I don't, at least that's my understanding. But the concept that you're proposing is really very good.
It comes down to a lot of this is more business oriented and not really. But the nice thing is it's not a technical issue. Most of the time we have to fight technical issues. It goes into a business. All right. Okay. Yeah.
Quick question. It's a great concept. I think it makes a lot of sense. Has there been a proof of concept system built? Has it operated, and has it operated under any?
Tell you right now, well, proof of concept, yes, definitely. We've done it. Proof of concept systems have been done. We've done that twice. But really, I think what you're getting at is an FOA, first office application, is really what you're getting at. Okay, and the answer is no at this point. We're on the verge of doing something, and I just can't comment on at this moment. But that's How does it scale? What a good discussion from the you can't do it to how does it scale. And it's a server. I enjoy that type of conversation because that means, if you got it on a server and you're following 3GPP, my confidence level is extremely high that we're going to get through this. We just, partly the reason why we don't have an FOA is if you look at it, whose network are we going to use right now? Because the big boys are pushing back on us, on this. So that's the only impediment that we're really faced with right now. But our foot's down on the accelerator right now as hard as we can. Okay.
And well, that was my question regarding the carriers that are out today and the competitiveness for them to create RMR continuing for them and to block out their other peers just by buying spectrum and keeping that spectrum inactive. What has their reaction been to this? Because you have the supply side and also the legislative side. You have to create a new method for the FCC to even manage this as well. So what are those? What are those two perspectives that you have?
Okay. Well, from the carrier aspect, we expect it to start with an MVNO process. Without the carrier's involvement directly. That's how we anticipate it. We expect that as this moves along, not the top two dogs, but maybe the second and third dog, or the third and fourth dog in terms of the wireless operator in the U.S. may come to play. They'll probably come to bat with us sooner than the big guys. But I say that as a pure speculation point. I don't have any facts to support this. But we envision to start off with an MVNO process. Now, with regards to regulatory pieces, which is very important, the short-term leases don't require regulatory. That's already in place right now. So we don't have any impediments at this point. When we begin trading the commodity back and forth, that's going to open up a whole SEC piece, and we're well aware that we're going to walk into that particular end, but we're doing that right from the beginning. All right. Okay.
Do you eventually see then an aggregation of quote unquote the RAN portion, one of the carriers, for instance, aggregating spectrum specifically so that you still have the operators operating, but basically one spectrum holder then becoming at 50 years down the road, one spectrum holder, spectrum to every, what we call today a carrier?
Yeah, one of our visions that we see going forward is that, as we push this thing forward, that the existing wireless carriers are going to focus on delivering service, not on owning spectrum. That's how we see it happening. Whether our vision is correct or not, but that's how that's how we're envisioning it. In the long run, it's going to be an interesting fight. Which will be good. It's going to play out. It's going to take many years to know which way it's really going to happen. There's going to be some, if it doesn't go all the way for a complete segregation of spectrum versus service delivery, there's going to be some in-between phase that's in there, but it's not going to stay the way it is right now. The genie's out of the bottle right now. All right, go ahead. I'll come to you in a minute.
I had a very interesting conversation a couple of years ago with Professor Dale Hatfield and some of his team back at the University of Colorado, who were looking at what happens to a network as the cell sizes get smaller and smaller, focusing on the fact that the limiting factor may end up being the bandwidth to send control information versus the user payload, and that the backhaul could become the limit. As, for example, we get 100 of us in here that move from this cell out of the room on break. Have you done any modeling on that as to the kind of limits we might be looking at as we get smaller and smaller cell sizes?
As we're going for the small cell environment for the backhaul piece, the simple answer is no. I haven't done modeling on that to find out when the final choke point is, as such. That's not been really my focus, to tell you bluntly. But the backhaul, if you don't have the backhaul, you could have all the front end RF that you want to have, but you're still choked. And then it's not just the backhaul. It's does your packet gateway and the external points going outside, do they have enough throughput in order to support it? It's not just a single point within the network. There's multiple choke points that occur, which frankly it's interesting. But, but to answer your question directly, no, I haven't done that at all. Okay.
So, with regards to the 3.5 gigahertz CBRS band, so there was a big flurry of activity with that earlier this year. It was supposed to be the small cell band. We had priority access, general access. We've seen some movement in that area that seems to have stalled. Google proposed to be the Spectrum Access Database, and Federated did as well. Do you see yourself with this as complementary to what Google and Federated are doing, or competitive? And also, could you give a perspective on whether or not you see CBRS is stalled and why it's stalled?
Okay. Oh, that's a pretty wide field you hit me with, but that's okay. To answer the question on the first part which is the fundamental premise of that database that's being used, I personally think it's fundamentally flawed. For the simple reason it's self-managing. Anytime you have a self-managing process, you're doomed, because nobody populates it. After day one, that database will be skewed right away, no matter what people say. I know other people will come out and say, no, the database will be right. I've always viewed it from the beginning. It's going to have a problem. Now, on the other piece, and I'm running out of time on this, but to answer the real, in coming back to it, yeah, it's complementary, and I think it's, possibly something like this could actually be done a little better. However, with that, with the white space, basically the 3.5, this doesn't really match up 100% with it, because DSA is based on having a network infrastructure to actually touch. For a lot of the white space, it's kind of not there at this moment. It's unclear on how they're doing it. So it doesn't really fit in some of this. But with Federated, on the key point, if you look at what Federated does and then you look at what we're doing, I think you're going to find something very interesting is there. And that's and I'm leaving that to your investigation to make you raise an eyebrow to one of the previous slides that I had up here that said, oh, plagiarism is the best form of flattery. Okay? All right. Thanks, John. Okay. Sorry. Okay. Thanks for the opportunity.
Sure. Okay, before I introduce the next speaker, I just wanted to remind you of a few things. In front of you on the table is a speaker rating form, and we'd like for you to rate all of the speakers and all of the panels. There's 4 attributes, and you choose from 5 to 0. We started this